So metabolism is just all the chemical reactions taking place in an organism. And chemical reactions do involve energy transformations. So some of these reactions are going to be releasing energy, and some of them will require energy. And each reaction is usually going to be catalyzed by a specific enzyme, and we're going to be talking about enzymes a little bit later. So there's two different types of chemical reactions involved in metabolism. We have anabolic reactions and catabolic reactions. So we can kind of restate our definition of metabolism. So metabolism is equal to all the anabolic reactions and catabolic reactions going on inside the body. So let's take a look at our anabolic reactions first. So what's going on in our anabolic reactions is we're going to be taking smaller molecules and joining them together to make a larger molecule. And this is going to be requiring energy to make this larger molecule out of these smaller ones. So when we have a reaction that requires energy, it's called an endergonic reaction. Ender just means inside or within, so it just means that you have to put energy into the reaction. And these anabolic reactions do need to be catalyzed or sped up by enzymes. And an example of an anabolic reaction would be a dehydration synthesis reaction. So we'll take a look at that in just a second. So the way I think about and remember anabolic reactions is I think about anabolic steroids. So if somebody is taking anabolic steroids, they're probably going to get really big muscles. And so I always think about like Arnold Schwarzenegger, and in his younger days in the movies, he was a pretty big guy because I'm pretty sure he took anabolic steroids. So I just think about that and think about how if you were taking anabolic steroids, you would look like Arnold Schwarzenegger and you would go from small to getting big. So that's how I remember anabolic reactions. You're taking these smaller molecules, maybe some amino acids, and making a larger molecule, like maybe you're putting those amino acids together and making a protein. Okay, and then the opposite will be catabolic reactions. So in a catabolic reaction, you're going to be taking a larger molecule and breaking it apart into smaller molecules. And when you do that, when you break apart the chemical bonds holding together this large molecule, those chemical bonds, when you break them, they contain energy, and so when you break them, you're going to release energy. And so when you have a chemical reaction that releases energy, we call it an exergonic reaction. So exer means outside or to release energy to the outside. And I just remember exit, and that's how I remember that it's going to be releasing energy. And these catabolic reactions are also usually going to be catalyzed by enzymes. And an example would be a hydrolysis reaction. So the way I remember catabolic reactions is I think about if you have a young cat in the house, they're pretty destructive. So they like to tear apart things with their sharp claws and destroy things. And so I think about how they would take something larger and shred it into small pieces. So that's how I remember catabolic reactions. So I think about young destructive cats. Okay, so let's just take a look here and do some practice. So over here on the left, we've got two individual monomers. Maybe these are two amino acids, for example. And we're going to end up over here on the right, and maybe we are starting to build a larger molecule of protein. And we're doing a dehydration synthesis reaction. Remember, synthesis means to make. And we're just squeezing out a water molecule to join those two monomers together to make this larger molecule. And notice we use an enzyme to catalyze or speed up this reaction. So would this be an anabolic or a catabolic reaction if we're taking two smaller molecules and making a larger one? So hopefully you said this was an anabolic reaction. And then if we do the reverse reaction where we take this larger molecule and we do a hydrolysis reaction, remember lyse means to split or break apart, and so we add water. We use the help of an enzyme to speed up our reaction here. And now we break this larger molecule into two smaller molecules, these two monomers here. So maybe we take this protein that we've been making and we split it apart into the individual amino acids. So would this one be anabolic or catabolic? So hopefully you said that it's a catabolic reaction because we're taking a larger molecule and breaking it into smaller pieces. Okay, so here's just another example. Here's some food that you've eaten. I don't know, it looks like you've eaten Lucky Charms or something. And when you eat your food, you're going to be doing lots of catabolic reactions to break down your food into smaller pieces so that you can absorb that and get that to your cells. And then you can see as you break your food down into smaller pieces, going from larger to smaller pieces, you are going to be releasing energy. And some of that energy is going to be lost as heat energy, because remember, we're never 100% efficient at converting energy from one form to another. So that's that second law of thermodynamics. And then here's some of these anabolic reactions where we're taking these smaller molecules and then making them into larger molecules. So maybe we've, eaten some proteins in our food, and now we're taking those amino acids and maybe we're going to make some proteins in our muscles, for example. Or, maybe we've eaten some fats in our diet, and now we're going to take those building blocks from the triglycerides and we're going to store them for later as fat, unfortunately, and maybe we gain some weight. So here's these anabolic pathways. So you can see we're taking these smaller molecules, making larger molecules, and we have to use energy to do that because anabolic pathways are endergonic. They require energy. They use energy to be able to make those larger molecules. Okay, and then here's just another picture just showing you these anabolic reactions are endergonic, meaning you have to put energy in. So you can see what we start with and what we end with. You've got to put energy in to kind of go up the hill to take these smaller molecules and then make a larger molecule. So maybe you're taking some glucoses and then you're going to join them together to make glycogen to store for later, maybe in your skeletal muscle or something like that. Okay, so you'd have to put energy in to join those glucoses together to make that glycogen. Okay, a much larger molecule. Okay, and remember, catabolic reactions are exergonic because they release energy. So maybe you start exercising and your muscles say, hey, we need a source of energy here to power our muscles. So they're going to take this glycogen and start breaking it apart into the smaller pieces and release that energy stored in those chemical bonds. And then that way we can use that energy to power the muscle contractions as you're exercising.